going to study now. The next topic is differential amplifiers. Differential amplifiers. Okay, I'm expecting everybody's ready. I said only 5 minutes, my friends, not half an hour break. So just message me that you came. You're ready to listen to the class. Just give a message so that I can start the class. Differential amplifiers. Meanwhile, I'll write the topic names. Topic names I'm writing what we have to cover in differential amplifiers. So I'll write some topics. How to cover differential amplifiers. First, we'll see the introduction to differential amplifier. I'll give some introduction to differential amplifiers. Introduction to differential amplifier. The second topic is differential amplifier classification, or we can say differential amplifier configurations. We can say differential amplifier configurations. Second topic, differential amplifier configurations. Very good. You're all ready. Great. One of the best interesting topic it is. Slowly we'll try to understand it. Maybe today we'll not complete. Tomorrow also it may take 1 hour extra time. Today 2 hours I'll teach. 3 to 5 I'll teach. Maybe networks will take from 5:30 today. So 2 hours I'll teach. By 5 o'clock I'll stop the class today. Half an hour extra I'll teach. So keep the heading. First topic is introduction to differential amplifier. The second topic is differential amplifier configurations. So how many type of amplifiers we can design is second topic. So after that, DC analysis. DC analysis of differential amplifier. DC analysis of differential amplifier. DC analysis of differential amplifier. Next one is AC analysis. AC analysis of differential amplifier. Of differential amplifier. In that we have two operations. One is differential mode. Differential mode analysis. Second one we have is common mode analysis. So in AC we have two mode analysis. One is a differential mode and one more we have is. Okay. So differential mode and one more we have is common mode. Okay. So Indra is an A here. So take only up to 4. Please don't tell like that because my class first is important to complete because I have a schedule immediately. Okay, Sunday I have a schedule. So compulsory I have to complete. You can request your network sir to take less time. Okay. Don't ask me to take less time. You can ask the network sir to take less time at this moment. First my class is more preference here to complete the subject. So 1 hour extra compulsory I have to take it. Please don't say like that. AC analysis of differential amplifier. One is a differential mode and one more is common mode. So if time is not there, definitely I have to miss the topics. So I'm not interested to miss the topics. So we'll complete. It may be a burden also we'll complete. Okay. After the class if you can listen this one. But class will be going up to 5 today. AC analysis of differential amplifier. One is a differential mode and one more is your what you can say common mode we can say. Two topics we have to learn. So after completing this, we have a topic called CMRR. So we are going to measure CMRR. That is called common mode rejection ratio. We are trying to understand how to measure it in a differential amplifiers. CMRR is nothing but common mode rejection ratio. After that, there is some techniques we are using called swamping resistor technique. These are the techniques we generally use in op-amps. So we have to understand some techniques now. One is called swamping resistor technique, one of the popular technique in op-amps. And second technique is current mirror technique, which we have already studied, current mirrors. So what is the technique we are using in op-amps? We'll see. Why use current mirror techniques in op-amps? There's one technique in op-amps to work out better. And one more technique is active low technique. So really speaking, whatever I have written the techniques, all these techniques we have been already covered in our subject. Active loads we know, current mirrors we have completed, and the swamping resistor is nothing but unbypass technique. All these things we covered. Just I'll give the overview for you. Why we are using these techniques? There is a overview for that. Samarish, as an enable here, management people will not do like that. Generally, up the gate and the ESC people have done this. If gate and ESC they are not kept at the same time, then this much of what you can say pressure will not be there for your teacher and for you also. This has been done that people. Our management has not done anything, my friend. For your sake only, they are completing by taking long hours. They requested us to teach. Otherwise, how can you complete the syllabus? Okay, so I think 100% is not sure to complete, but they are completing everything for you. The main reason is that one. So you have to give appreciation to management. You should not say like that. Okay. They are thinking about you. That's why they are making requests for us to do all these things. Maybe it is creating a pressure for me, but also we have to teach because it's my job. Study is your job. Teaching is my job. We should not feel pressure. Okay. Never feel pressure like that. Whenever hard times comes, then also if you are cool in nature, then you'll be good in life. Always remember this point. I never feel pressure for anything here. Okay? It may be 10 hours also, I teach like this one. So it's my job it is. I feel it's my job to complete. So like that you also, maybe suppose 10 hours follows you're working hard. So don't feel it as a pressure. If you feel pressure, it will become a pressure for you. If you don't feel, it looks like enjoyment for us. Okay, we're learning some new things, we're trying to understand it. If you feel like that, you sit for 20 hours also, it looks very happy for you. So like that you feel it, Samresh. Okay? Always be cool in life. No burdens will come in your mind. Okay? That is most important for a human being. So write down these 8 topics. This 8 topics is my today story. It's not a subject, actual story. There's an order of story for us to understand. How op-amps became an ideal op-amp. We'll understand these techniques. So maybe it requires some 3 hours time. Today we are getting some 1 hour 45 minutes time up to 5 o'clock. How much I can complete today? I'll complete. Remaining thing tomorrow we can complete. After that we are starting immediately op-amp basics. We are going to start in the morning class. Afternoon class applications. Slowly we'll learn like that subject now. Okay. Maximum we'll finish by Friday this total subject now. So introduction to differential amplifier. First topic. Second topic is differential amplifier configurations. The next topic will be DC analysis of differential amplifier. Means any amplifier will have two things: DC analysis, AC analysis. Cascode. We done DC, we done AC. It's a Darlington pair. We done DC, we done. It's a common thing in analog electronics. The nature of mind you have to accept it. And next we have CMRR, and we have some techniques in op-amps. One is the swamping resistor technique that one is current mirrors, one is active loads. my friend, revision you have to do after completion of the syllabus. Now at this point we have to understand the subject only. The revisions don't keep. Okay? It is not a chance to revise now. It's only to listen the class now. Yes, Shovik, thank you very much for understanding. Sleeve rate, Samresh, sleeve rate will come in our syllabus, but the SMPS is not in our syllabus. SMPS is different. It's a power supply concept. Okay? SMPS is not in our conditions to study. Sleeve rate compulsory in our class. Tomorrow class I think applications will get sleeve rate. There I'll explain you what is sleeve rate. It will tell about the speed of your device. Okay? Sleeve rate indirectly means speed of the device. Okay. Let us start our first topic. Introduction. Where is the first topic we are entering? Introduction. Introduction to differential amplifiers. Differential amplifiers. So try to understand the simple basic meaning of differential amplifier. Suppose tomorrow class, if I want to show an op-amp, I show like this, op-amp. With a symbol will show, there will be one negative, positive for the op-amp with two terminals as an input, and we'll have the one output. This is something special amplifier where it will have two inputs with one output. So this input name is V minus input, this input is V plus input. So we have here plus VCC, and we have here minus V. So this is a way of representing an op-amp. Tomorrow, in every diagram, you'll see this symbol. The symbol, what is the meaning of this? What are the indications? Let us understand. Up to till now, common emitter amplifier we have seen, common source we have seen, common collector we have seen, everywhere, only one input will be there. Base is input or emitter is input we have seen. But here in this case, a differential is a special design. He prepared, there are two inputs he has given for it. Two inputs means we need two transistors to become two inputs. So that is the technique of this amplifier. So this V minus and V plus, indications I am writing. V plus indicates here non-inverting input. Non-inverting input we call this as. Non-inverting means if any signal if you do here, the output will come in phase output. Okay, same thing amplifies in phase. So that's why it's called non-inverting input. And this will be given as a name, inverting input. This is called inverting input. One is non-inverting and one is inverting. If you give signal here, it will get inverted here. So if you see here, suppose if I give signal like this, inverting side, your output will get amplified like this. It will give 180 degrees phase shift. But if I give signal here, suppose, you will get the output like this, in phase. So these are two different ways of inputs. One is 180 degrees phase shift also I can bring from the op-amp. One is a zero phase also we can bring. But if you go for a basic amplifiers, common emitter will give 180 degrees phase shift, common base amplifier will give in phase. But here both amplifiers are there at a time. Both amplifiers we can have. Okay? Pandit, that we'll see at the end. Okay? The tips I'll tell you at the end, gate exams curve. How to prepare, I'll tell you the tricks. At this moment, please complete the subject. So whenever you have a signal, we have the out of phase. Whenever the signal is given here, it will become in phase. The next point here is, if I want to prepare this type of amplifier, two inputs, how to design two inputs here means, you can see. The differential amplifier inside how to design is, you take here Q1 transistor like this. This is one transistor Q1. And just to couple this transistor at the emitter side with another transistor called Q2. So like this, you take a pair of two transistors to design a differential amplifier. So two transistors I have taken and join this two transistor emitter point with one resistor called RE. Emitter resistance with a battery called minus V. Apply negative battery for biasing circuit analysis. Whatever you're seeing here, negative battery, that is a negative battery inside the differential amplifier. Top side, we have some resistance, RC, and join these two resistors with a common point. And here you connect to VCC. Now you can see this is one terminal and another terminal will be taken like this. So these are your two terminals. This is the inside design called differential amplifiers. Okay? There are two transistors you applied. For example, if this transistor is being notified with V minus, if this is notified with V plus. Suppose for example, that is V minus, this is V plus. Then you have the outputs. If I take the output, we can take only one side output, that is V naught to ground. So any one side you have to take. Whether you take from Q1 or Q2, according to the design we can change. Suppose in this example, Q2 transistor is taking the output. So this is the situation we are seeing. If I give suppose from here the signal, that output will come 180 degrees phase shift. If I give the signal from here, that will give the in-phase output. So this is the meaning of a differential amplifier. Differential amplifier always requires dual batteries. It requires one negative battery, is my observation. It requires one negative battery compulsory for biasing. Negative battery is required, and it requires a positive battery. Two batteries are required. Positive battery. One positive battery, one negative battery is required. And the output will be only, single output will be there. Only one output. Okay? V naught is considered to be your output. This is called output voltage. So this is the brief description about your differential amplifiers. And whenever you are designing this differential amplifier, the rule is, conditions should be remembered is, to design a differential amplifier, first rule is very important is, Q1 and Q2 should be identical is important. Should be identical is important. This is a very important condition to design a differential amplifier. The two transistors what you take, okay? The two transistors what you take. Yes, this output is grounded here. If I don't show anything, the meaning is ground. So it should be identical means, beta 1, beta 2 of your transistor should be same. Exactly you have to take the equal beta of the two transistors. That is the rule number 1. And the resistors, whatever you take RC, RC here, your RC1, you make it as RC2, and you make it as RC. And make the symmetrical resistors as loads. RC1, RC2, you make it as the same resistors. These two things are very important to follow the design of differential amplifiers. Don't say that, sir, I'll take here beta 1, I'll take beta 2. We should not do like that. Okay? The main principle is behind that. We need an identical system such that any noise comes from the outside, it will try to reject the noise with the technique. So we need a symmetrical circuit. So this is about a small introduction about a differential amplifier. I'm expecting it's very clear from the board. What is a differential amplifier? What is a differential amplifier? I hope I understood. I'll write here in quotation, differential amplifier. Differential amplifier is the input stage of op-amp. So it is not more than an input stage of op-amp. That is the basic knowledge about differential amplifiers. We are designing the first block in your op-amp as a differential amplifier, which will work as an input stage of op-amps. So today we are studying the input block of op-amp. Tomorrow we are understanding the complete package of op-amp. Okay? Inside op-amp there are certain blocks. There's only one block I'm studying today, how it is going to perform. If I don't know the first stage how it is performing, we cannot tell the behavior of the op-amp. That's why this class is most important to observe and to understand the class. Okay? So smoothly you can complete. Let's see, if you are getting tired by 4:30, if you are getting tired, we'll stop there. Because my heart will not accept if the student is getting tired like that to study the class. Okay? There's one more weakness I have generally in offline class also. If the student says, sir, it is becoming more burden. Okay? At the time I'll say that we'll stop the class. Because according to the student, I'll teach actually my classes. Okay? In my way, I'll never teach. I'll see the faces of the students. If they're convenient to understand, then I'll teach. Otherwise, I'll take a break from the class and I'll go for the next issue in the next classes. It is not important for me to complete the topic on time. Okay? It is important for me that the student should be flexible to understand the subject. That is more important for me in my classes. Okay? Take the 4:30 go if it is. If you are convenient to understand after 4:30 also you are able to understand, able to listen the class, okay. Otherwise we'll stop it, no problem. Okay? In half an hour I think there will be no wonders will happen in half an hour. Okay? Let's see how much we can complete. Now it is 3:30. Let's see within 1 hour maximum how much I can complete. So this is my first topic. So complete the first topic. Yes, Sri Krishna, all topics are interesting only. Every student is feeling happy, I'm expecting. The only thing is morning to evening you are sitting. Maybe due to that your eyes will be paining. That's why you may say like that some students. So for that reason I'm thinking whether I have to teach up to 4:30 or 5. I'm thinking, let's see. How much time I can teach, let's see. The topics are interesting here. Each topic is interesting. In op-amps, if you see, every topic is important, every topic is interesting. Yes, Swati, half an hour will not make any issue. Let's see, according to the topic. You will not see the time also. It will be gone like that with these concepts. So please complete the first topic is ready. Let us start with the second topic called configurations how to design. Is the next topic. Okay, thank you, Roy. Swati, thank you. Yeah, Majender, what you said is correct. So they have been thinking about second wave or time waste. According to that, pressure has increased for us. Anyway, if you want to target something, the pressure also we have to overcome. Okay, if you can do like that in future, will be the best. Already, Shabnizas is asking me why we are using 2 batteries. If you want to understand that, you have to wait for topic number 3 called DC analysis. Okay, topic number 3 में समझ में आते हैं. At this point, 2 batteries are required. I cannot explain you why 2 batteries at this moment, but in DC analysis, I'll explain why I take 2 batteries. So shall we start? Shall we start the second topic? Keep the heading. Second concept: differential amplifier configurations. Keep the heading differential amplifier configurations. This is an easy topic to understand. Just is telling how many configurations you can design. So there are 4 types now. Type 1, type 2 are like this, I'll write. Just please draw it, don't waste the time. Type 1 I'm drawing. Parallel to me you draw it. Parallel you draw it. Don't waste the time. So we have 2 transistors. We have RE. Here PE. This is RC. We have RC. This is C. We have 2 inputs. Just write the skeleton view first. Then I'll explain you how many ways I can make the structures. Type 2. First complete the structure first. In all the things, same structure you write first. Then I'll explain you what are the extra things I have to change. Same structures, develop it. This is type 2. Type 1, type 2. Write all the structures same. I'll show you the small changes in the configurations. Type 3. Type 3 this. Type 4 I want. One more diagram. So be ready with 4 diagrams. We'll finish off the topics. So I'm ready with 4 diagrams. Akshan Kumar, let's see. Thank you very much. So 4 diagrams you draw it like this. So what are the differences will come in 4 amplifiers? I'll show you. I can use this amplifier in 4 variety of modes. Type 1 I can use, type 2, type 3, type 4. What are the differences, in which manner I can use it? I'll show you the techniques now. First complete the 4 diagrams. So if you have copied, just see one time the story now behind this. How configurations can be explained. How the configurations we can explain. I'll take some color here. First I'll come to first type. This is the first type you can see. Type 1. Type 1, how I'll use it is, suppose at this point I have given my input. I have given my input signal here. I'm interested to give signal at the one point of my transistor. Other side, I'm not interested to give. So that means I understood that this amplifier can be used for single inputs. Single input also it is performing. That's the point you want to tell. So in the coming classes in op-amps, whenever you have 2 inputs, there is no meaning that I have to give 2 inputs all the times. We can do 1 input also. That's why in electronics we have 2 amplifiers. One is inverting amplifier, one is non-inverting amplifier. So this is called one way of operating. Single input I have given, but output whenever you take, I can take both outputs like this. In between, you can take output in this manner. So this is one type of output. The output can be taken from the two transistors. Okay, that is one type of classification. This is a single input we have taken. That is a common output we have taken. Common output we have taken. Whenever you take like this, it got a name. This amplifier got a name. That is a single input. We call this as single input. Whenever you take output across C1 and C2, two transistors, this is Q1, this is Q2. Single input, we call this name as balanced output we call. So balanced output. What is the meaning of balanced output is output taken across C1 and C2. We call it as balanced output. So whenever you take both the outputs, we call that situation as balanced output in electronics. So single input, balanced output. We made a configuration. Similar manner, we'll go for next diagram. Here we'll go single input again. We'll make this as ground. Second one we'll make it ground. But here what I'll do is only one side output I'll take. Only one side output. That is across C2 I'm taking. So only one side output also we can take. So this configuration will change again. This is called as single input, but we call this name as unbalanced output. Unbalanced output. So there are two different ways of outputs. One is called balanced output, one is called unbalanced output. Unbalanced output means the output taken from one transistor. Output taken from one transistor. If you take from one transistor only, we take it as unbalanced. So balance is different, unbalance is different. So according to that, maybe characteristics can change. The next one is, in this case, what I'll do is VI1 I'll do here VI2 I'll do. So in this case, what I've done is both the inputs I'm giving. That also you can do. At the same time, you can take both the outputs also. Between two transistors, you can take both the outputs. So this is another way of designing the amplifier. So whenever you take two inputs, we call it as dual input. It is dual input. Balanced output we have taken. Balanced output. So balanced output we have taken, dual input we have taken. And the last topic if you see, I'm thinking you're writing parallel with me. So last input. Here also we'll take two inputs, VI and 1. This is VI and 2. But output will take it as only one in. So we can take two inputs from the two transistors, but output will take only one output from one transistor. So it is called dual input, but it is unbalanced output. Unbalanced output. So this is the way we have variety of amplifiers we can design. From the single structure, we can design 4 types of amplifiers. Yes, Sneha Kumari, whatever the doubt you have, output not only here, you can take from here also. That is the choice of the designer. Designer can take from anywhere. That will decide the inverting and non-inverting in electronics. So for convenience, I take on the right side, not on the left side. Okay? Anywhere you can take, no problem. But the rule is only one side you have to take. Whether Q1 or Q2 you have to take, which we call it as unbalanced. Because they are not balanced because only one transistor you are taking. When one transistor output you take, it is called unbalanced. When you take two transistor output at a time, we call it as balanced. So I have to explain all this first. Nice approach. So this completes my second topic. Okay? Each step is a simple logic to understand. So first two topics are completed. Just note on it clearly. We'll start the topic number 3. Start the topic number 3. Please complete it. What is the difference from take output C1, C2? If you want to know the differences, why we take like this? One output, two outputs. If I take like this, what happens? Nothing will happen. The characteristics will change. The voltage gain will change. The input impedance, output impedance. We'll see in the AC part, this analysis. Okay? Summarize at this point, I cannot tell you what is the difference between output and V0 is the difference I have taken V0 between C1 and C2. That will be explained in DC analysis and AC analysis. How to answer that question? We'll see in the DC and AC part. So please complete up here, you'll get the subject knowledge in DC part and AC part now. Here understand how to write the configurations. Don't go further topic. If you go further, you'll get headache. Nothing is there. Because I have to teach the points. You have to wait for it. We'll see in the DC and AC part. And from this, if app is not opening, you have to contact the technical team. Okay, not for me, you have to say these points. Technical team by Parker. So this completes the second topic. So let us start the concept number 3. That is called DC analysis. DC analysis of a differential amplifier. The beautiness of this topic is, whatever the configuration you have, the DC model will be same for all the 4 cases. So it will look like this, DC model. You'll see ground here. Here also ground. This is RE. This is battery, minus VE. We have RC. And we have RC. VCC. This is Q1. This is Q2. This is where you are seeing the model. So in DC model, what we have done, very simple thing. Only yes, here no capacitors, nothing is there in differential amplifiers. If capacitors is there, we have to open it. But in individual electronics, taking capacitors is the biggest size. That's why we removed it and we prepared an amplifier like this. We don't have coupling capacitors, we don't have bypass in this amplifier. So it's a beautiful amplifier, which is a small size amplifier we can say, where it requires only 2 transistors with some resistors we have taken. So can you see that only AC we have to make ground. If you take dual input, I'll make this ground, that one. If you take only one side, then I'll make it ground. So whatever may be the configuration given in the exam. Summarize, you can take here C1 से भी ले सकते, C2 से भी ले सकते. Okay? Balance चाहिए तो we have to take both the output is steady. If it is unbalanced means C1 to ground or C2 to ground. Any one case you have to take the output. Okay? That is the meaning what I want to tell. So this is Q1 and Q2. We have two transistors in the class now. So now the point is, any signal conditions are grounded means for all the configurations, this model is accepted. So DC model is accepted for all the configuration. This DC model is accepted for all configurations. So any configuration, this is the DC model. DC model is accepted for all configurations. So what is our today task is in the class? You have to find out the operating current in the class. That is your ICQ how much. This current is also ICQ how much. So you want to find out the operating current in this circuit. So if you find this current, I know this current because both are identical transistors we have taken. So I want to find this current. Then what is the logic here? Some students are asking, why should I take this battery? Why can't you take only one battery VCC? If there is some trouble is coming for me. What is the trouble you can see in DC analysis? As we made this as ground, can you see that there is a diode here between base to emitter? And here also we have one P junction diode between base to emitter. Currently if you observe why these people are taking the here negative battery, you should have a common sense on the circuit. After listening some 70% of your envelope classes, you must get a feeling that why he kept a negative battery means one side you are making ground because signal has to become ground. That means the anode of your diodes are ground. Then cathode also if you make ground here, your diodes will become cut off. And diodes will not be on, they will be cut off, but we want to become active. That means biasing is a word we are applying to make the transistor to be on. That means here my choice is not making on one transistor, I want to make all the transistors on, so that each transistor can work like an amplifier. So in active region, we have to keep these two transistors on. To make it on, what I have done is, I kept a lower battery here called minus VE. This minus VE will go to the cathodes of these two diodes, and other side you have a zero, which is higher potential. So both sides higher potential is at anode, bottom side you have a negative battery, which makes these two diodes to be on. That is the main reason we need a dual battery there. If you don't keep that battery, so I think your transistors will be off. That is the main purpose of using that batteries. Yeah. To make it in active region, these two diodes, this battery is important. So whatever the battery you have taken here, the main purpose is, this will make this diode to be on. And this battery will make this diode to be on. So these two diodes will get on. Means two transistors will work in active region. So it will give a potential of VBE here. If it is on, it will give VBE voltage. Here also it will give VBE voltage. Then if I ask you how much the voltage here, it is 0 minus VBE will be here. Otherwise 0 minus VBE will be here, which is a common voltage, which is minus VBE will come here. So this is the investigation I have done. How much that center potential value is, minus VBE is the value. So one time you decided this is minus VBE in the class. Two diodes are on, 0 minus VBE became minus VBE, 0 minus VBE became minus VBE, both the diodes are on at a time. So can I say now the current flowing here how much? If I want to solve the current here, one current is coming from this branch is IE current. And one DC current is coming from this branch is IE current. So automatically the current in this common branch will be 2 IE current. So I think the current going to RE is not IE, it is 2 IE current because both transistors are giving 2 emitter currents are coming because two diodes are on. So to find 2 IE current first, 2 IE current, what is the formula we can apply is this voltage minus this voltage by RE. So minus VBE, minus of minus VE divided by simply RE. This is 2 IE current I found in the differential amplifier. It is called 2 IE current. Okay. If you have any server issue, my friends, okay, in the recording video, night take away, but by 4:30 I'll stop the issues. Okay. If anybody has some server issues, in the class I think it is coming for us. But why it is not coming for you means maybe some problem will be there. Unable to join, no problem. You can listen in the recording video. This extra part what I am teaching in the class. Okay. Who has not joined, leave it. Who is having it, they can listen. Who is getting, they can listen. Other people see in the recording video. 2 IE current is minus VBE minus of minus VE divided by RE. Okay. Then what is here? Answer is 2 IE current will be equal to VE minus of VBE divided by RE you can write. This is your 2 IE current in DC analysis. This is the way how we are solving the 2 IE current. Now the point is, this IE current and this IC current will be approximately same. So IE is approximately equal to IC. The rule is the beta is high because in integrated electronics beta we take high. So IE is equal to IC we can take with this condition. So we can write in place of writing IE here, we can write it as ICQ. We can write in place of IE I can write as ICQ is equal to VE minus VBE divided by RE. But you are asking the operating current of each transistor how much. If you want operating current of each transistor, ICQ will be equal to VE minus of VBE divided by 2 times of RE. So this completes the operating current, okay, per transistor. Per one transistor, this is the operating point. So per one transistor, this is the operating point. Yeah, Sri Krishna, definitely. App will have some issues here. Sometimes it happens, no problem. This video will come as a recording video. You can find out some time to listen this class. Okay, who is missing? They can take rest. Okay, 5 o'clock, be ready for 5 or 5:30. Be ready for the networks course. For the next class, who cannot join it. So maybe internet issues will be there sometimes. Okay, all troubles will be there. So finally, I think I finished the story number 1 in the class. That is how to calculate the operating current in your differential amplifiers in a smooth manner. I completed it. So that means every time remember the two transistors, whatever you have taken in differential amplifier, in DC analysis, they'll be on always because of the target called negative battery applied here. If such a negative battery is not there, we have only VCC. These two diodes will be always cut off. If you want to make it on, that negative battery should be present. That's why in op-amps compulsory we see 2 batteries, VCC and minus VE compulsory. So please complete up with you. So this completes my topic number 3. So each topic is completed in a smooth manner, try to understand it. So only one topic will be the major role today, that is called AC analysis. Maybe one thing I'll do today, the AC part I'll cover today. Tomorrow class when I come, CMR, one topic is remaining, and the 3 techniques I'll explain. With that the total module will be completed. Today only one topic, which may take half an hour class. By 4:30 max I'll try to stop, because some students I think app is not working that really, so it is not good to extend the topic up to 5. Okay? Maybe by 4:30 I'll stop these concepts, let's see. Otherwise refresh, if any students are not getting trouble, please refresh and see one time. Try to refresh it. Refresh and see. Okay, actually rain is falling today. Again rain started to flow. Some reasons will be there for this. So topic number 3 is also comfortable to answer the question. Operating point finding is easier. V minus VB divided by 2RE will be the operating point for a transistor. I'm not teaching for 2 transistors, I'm teaching per transistor. It's 1 transistor operating point. So that means who can solve this current? If suppose this current is 2 milliamps, you can write here 1 milliampere, here you can write 1 milliampere. Like this also you can study. Bottom current to find out karo and make it as 2 halves because both transistors are identical. Both the transistors are identical. Okay. Okay, app update is coming, version 5.3. Maybe I think they're updating this version, I think. Due to that, maybe for half an hour or 15 minutes you'll have a problem. Again, you can come back, log in, and you can listen to the class. Okay? Hardly takes 10-15 minutes probably it is. So if it is completed, please tell me. I'll proceed to the very important topic today. The 4th topic is the most important topic to understand today. That is called AC analysis of analyze for a differential amplifier. So let both side minus VB due to that common taken. Yeah, Arpita. For every transistor we have an operating point. Okay? That we decided like this. Each transistor operating point. Individually how much? I investigated. Next is very important topic, 4th one. Point number 4. AC analysis. AC analysis of differential amplifier. This is the main topic for you. The other topics are simple only. This main topic you have to understand. One of the typical concept. AC analysis of differential amplifier is the most important idea. So let us understand this in a beautiful manner. AC analysis you want. If I want AC analysis, what to do is, suppose if I take your differential amplifier like this. In AC wise I am doing it. This is RE. In AC I think your DC should be ground. Your DC actually should be ground here. Here we have RC. Here we have RC. Supply should be ground. Supply should be ground. So you try to see AC analysis like this. Whenever you go for AC, the DC should be grounded. Okay? So here VCCs are grounded. Here VE is grounded. VCC is ground means both sides you can separate it if you want. Thank you, Arpita. Thank you very much. So this side is ground. This side is also ground. Both sides are kept ground VCC and VE is also ground. Now the point is, for example, I have given a signal here V1. I have given a signal here V2. Carefully listen to the concept. One side signal is 1 millivolt sin omega t I have given. Small signal. Here also I have given, but different signal I have given. 0.9 millivolt sin omega t. If you clearly observe the concept, one side you have given 1 millivolt sin omega t, one side you have given 0.9 millivolts. It's a very slight difference in the two inputs. A small difference I have given. So how it will behave as a differential amplifier, you have to understand. I kept a wall here. You can see the boundary wall. Here also I kept some boundary wall for this. So why I kept a boundary wall here? Some imagination is required. Try to see what is that imagination. Why I kept a boundary wall here means outside what you are feeling, inside is going different. Outside you are telling V2, but inside is going something different. What is the different you can see? Suppose in first case, I have taken my transistor like this. To understand better, this is an extra work I am doing. See here. This is another transistor. We have RE here. This side, suppose I made it as ground. This side I made it as ground and make this as grounded. We are not interested in the top. Here I am giving some V1, that is 1 millivolt sin omega t. This is one example. This is Q1 and this is Q2. Second example is same Q1 transistor. This you take it as ground. This is Q2 and this is RE. This is ground. Correctly see the concept here. I am doing 2 experiments in the board where one signal when I give other signal I am making ground for some time to understand the concept. And if I give the second signal there, what happens to the first transistor? So individually I am seeing what is happening. This is 0.9 millivolts sin omega t. So I have given 2 separate signals into situations. What will happen? We'll see. This signal can have a chance to go where? Your base current started traveling with this concept. Your base current started traveling like this. This is your IB1 we can say. Base current IB1 started. Where it will go means, it will come here like this. It will be coming in this manner. This current will come here. Whenever the current comes here, have you seen that? This current have 2 paths. It can go down or it can go to this transistor. It has 2 positions to go. So it is offering here how much resistance in the board is. This transistor is offering a resistance of R pi. It's offering a resistance of R pi for the base current. So one is also not required. You write I, some current. You take this current name as some I1 current. So this I1 current is moving there, which is a base current you can say. That current have 2 paths. It can go to RE, it can go to R pi. That is having 2 chances. But the current name is IB current in the class. You have a clear cut idea. You write this as IB current. This is your IB current. If this IB current comes here, IB current comes here now. How much resistance this RE will offer? R pi is a resistance for IB, but RE is not a resistance for IB. So how much resistance it will offer means, it will offer extra 1 plus beta times. Resistance is offering for the base current to go there. Because resistance will increase if the base current want to go to RE. So if you see the difference between these two in the class, that is only R pi, this is RE into 1 plus beta for the base current. You assume that this is a close to 1 mega ohm, high resistance, this is close to 1 kilo ohm. So this is the difference between these two resistance in the board. R pi is a close to 1 kilo ohm resistance, but 1 plus beta times of RE will become close to 1 mega ohm. So when you have 1 mega ohm and 1 kilo ohm path, definitely I think your current, the current will start to flow this side. It will enjoy the current to flow this side to this side. So can you see that your base current is not showing interest is not showing interest to move this side, it's showing interest to go this side. So this is the one point I observed in the class. So whatever the signal current you are inducing in the Q1 transistor, it is bypassing to the Q2 transistor. That is the first observation done by the experts. Okay? In a similar manner, if I take signal here, you have here R pi 2, this side no? This is R pi. Same story will happen for this also. The current will start here as IB, this side current. The same current will come here IB. But this current will go this side. This is IB, this current will go IB, and this current will go IB. So the current will go to this side. Where RE side, the current is not showing interest because it is 1 plus beta times of RE. Because of 1 plus beta times of RE for the base current, it is showing very high resistance. It is showing only 1 kilo ohm, but it is showing 1 mega ohm. So current will not show interest to go to high resistance path. It will show interest to go to the low resistance path. That means that this current is mixing with the V2. V2 is mixing with the V1. So finally I understood that whenever you are sending this voltage and this voltage, this RE resistor is looking as a open circuit. This RE is looking like practically as an open circuit in the class. Yeah, I hope you understood this idea. According to this knowledge I understood, V2 whenever it came inside, that is not V2, it is mixing with V1 voltage. And V1 voltage is mixing with V2, so there is a mixing parameters are coming inside the device. So what is the mathematics for this means? He has written here the formula as V1 minus V2 by 2 mixing voltage plus V1 plus V2 by 2. Like this they divided the components. This side he has written V2 minus V1 by 2, higher minus lower you have to take. So here what happened is lower minus higher difference by 2 plus V1 plus V2 by 2. This is a very popular way of imagination they started. This is not a formula creation, it's an imagination. That whether whatever the creation you have done the formula inside, this has to match with 0.9 here. This combined answer should match with 1 millivolt. That is a proof for that formula. Whether that formula, whatever you have written inside, will satisfy your condition or not. Let us have a testing for that. The formulas are very easy to remember. Difference you have to take V1 minus V2, one side. Other side you take V2 minus V1, but you take half of, because both the difference they have taken half of. And the other thing is addition of an average of two signals, V1 plus V2 by 2, V1 plus V2 by 2. So what is this intelligent idea? Let us understand. Why should I take formula like this only means, whatever the answer you created here, this total answer should be equal to 1 millivolt has to come, because you applied 1 millivolt. This answer exactly should be equal to 0.9 millivolts, then your mathematics is correct. Okay? So here, you should not say that, sir, how to prove it, that is not the meaning. Here, how the result is correct or not, that is the meaning. Because they are not derived anything. They imagine that way of differences when you take, the answer should satisfy the value. Such that they added some extra term here, V1 plus V2 by 2, which is nothing but a common signal we can say. Common between the two signals is called common mode. So let's see whether these two answers, whatever I have written, formulas are correct or wrong. Let us justify it. And the total story will revolve with these two formulas today. So whenever you send some signal from outside, that will mix with the opposite signal. That mixing formulas he has written nicely like this. At the time, you have to feel that this resistor is open circuit, because it is offering a very high resistance for the base current. It is offering 1 plus beta times of IB. Divya, thus, sir, why we are doing this? The question of meaning here, without knowing inside knowledge, why the currents are mixing inside? What is the nature of the formula for that? If I don't know that, how you will go to the research here? How the person will start research on that? This much valuable techniques there. Why we are all doing this? What is the meaning of that? If I don't do this, how can you teach the mechanism of differential amplifiers in the class? Because of this simple knowledge, I can develop the complete concept of differential amplifiers. Okay? That question is a wrong question. What you are asking? That's a wrong question. Why you are doing this? That is a wrong question. If you don't do this, how can you explain the characteristic of op-amps? How can you explain differential amplifiers? Okay? What I believe outside is happening inside is different. That you want to tell. Both the signals are mixing each other. Is the trick I explain. Okay? If I send some current here, it is mixing with the V2 signal current. When I am sending some current here, it is mixing with my V1. So that mixing formula he created like this. So that formula is correct or wrong. Just we can verify it and we can satisfy and we can start the subject. So let us see these two formulas separately. We'll develop the concept now. So now onwards we can write V1 as this definition. V1 now onwards we can write inside the differential amplifier as V1 minus V2 by 2 plus V1 plus V2 by 2. Like this we can write. And V2 you can write it as V2 minus V1 by 2 plus V1 plus V2 by 2. So like this you can develop it. So I'm expecting it is completed up to here. Let us move to the main steps. So please practice these two formulas which are very valuable for our op-amp discussion. So I'm going for analysis. So now onwards, V1 we can write it as V1 minus V2 by 2 plus V1 plus V2 by 2. This is the first formula. V2 can be represented inside the differential amplifier as V2 minus V1 by 2 plus V1 plus V2 by 2. These are the two formulas we are expecting. So there are some meanings about these terms. You can see VD, one important term they have developed, which is V1 minus V2. So from this formula, I'm creating some new terms for you. VD is a very important term in differential amplifiers. It is called as a differential voltage. A differential voltage is a difference between two voltages. V1 and V2 difference, we call it as VD. Differential voltage. Okay. Differential voltage. VD is V1 minus V2. V1 minus V2. So we can call this as differential voltage. Differential voltage. Differential voltage. And there is one more term they created is VC, which is V1 plus V2 by 2. Now onwards we call this as common mode voltage. Common mode voltage. So why this op-amp engineers will tell in AC analysis two modes of operation means, this is the meaning. Your signal, whatever you send into the amplifier, op-amps, that will try to divide into two parts of this. One is a differential mode, one is a common mode. Common means nothing but, for these two signals, this is a common signal we are getting. V1 plus V2 by 2 is nothing but the average of the two signals. That we call it as common signal. Common signal we are not interested, we are interested on the differential signal. So this is unwanted here, this is wanted for us. So common signal has to reject, differential signal has to come out. That is the meaning called differential amplifiers. Okay? And some students, if you want to imagine that formula, I'll give as a conclusion. Okay, afterwards, first understand the good terminology. Imagination I can do for you. How it is coming, what is the imagination needed. I can explain 5 minutes. First understand the picturization, how he's writing the names. What is the VD, Sir is telling, what is VC. These are all the golden steps for my op-amp calculations now. So carefully listen the points first. How the formula V1 is written. The doubt I'll clarify. Don't worry. First complete this topic, then I'll clarify it. So VD, VC we have written like this. Then can write V1 as again simply VD by 2 plus VC. This one answer. V2 is equal to minus VD by 2 plus VC. So you can just move to this action to this and move to this action to this. So this is the way how you can remember these formulas. V1, V2, easily you can practice like this. V1 minus V2 for VD, you have been explained. So VD by 2 I have written. VD by 2 plus VC, common mode voltage. It is minus VD because V2 minus V1, so minus VD by 2 plus VC. These are the standard formulas. Who is not understanding or who is not getting these formulas, they cannot develop the concept of op-amps. Most of the students, I think, they feel tough this only. Most of the teachers also, to explain this, it will be very tough for the teacher. Let's see how I'll use a visualization for you. I'll use some visualization so that these formulas will be registered in your mind throughout your life. So take down these formulas. This is my 2 inputs in the differential amplifiers. When they mix each other, this is my story. So now the concept is, we can have 2 modes of operation. AC mode of operation. AC modes. AC mode of operation. We can do 2 mode of operations. AC mode of operations. So we have 2 modes of operation. The first mode we call it as, first mode is called differential mode we call. Differential mode. So whenever you do this analysis in the class, whenever you are doing differential mode analysis, the person is telling that don't consider the common mode value, make it as 0 in the class. So whenever I am doing some AC analysis in differential mode, common mode voltage have to be 0. Whenever you make 0, your inputs will be changing here as VD by 2 will become our one input, minus VD by 2 will become the other input. So these are the 2 inputs I give to the amplifier to study your AC analysis for the differential amplifiers. Don't take the complete equation for study because we are dividing into 2 parts. Common mode analysis separate, differential mode separate. So differential mode when you study, VC common mode voltage should be 0 for that. Coming to the second one, concept number 2. Differential mode, after that we have is common mode we have. Common mode. Second mode is common mode we have in the class. Whenever you take common mode, you have to say PD is equal to 0. Your differential mode should be equal to 0 we have to take. Okay? Differential mode has to be 0. Then automatically your common mode inputs will be VC. So both the inputs will be same here because the other 2 answers will be 0. So tomorrow class I think we'll try to visualize these 2 things. Maybe tomorrow we'll stop here. I'll give 5 minutes explanation about the sign. That formula how it came I'll explain and I'll stop it. 4:30 alright. Tomorrow class we'll start by 8 o'clock. Half an hour before only we'll start the class so that this content we can finish off. Okay? Now 4:30 to 5 not tomorrow morning you'll be fresh to understand this class very well. But before that, today to leave this class, a small idea I'll give for you. Why that will be taken like that? A small explanation for you. So that you'll be happy in understanding the point. So please complete this. So today class just give 5 minutes. 4:30 I'll stop the class. So up to here, if it is clear, just I'll give a small conclusion. To end of this class tomorrow. Tomorrow time is 8 a.m. Morning 8 a.m. start the class. Tomorrow 8 a.m. 8 o'clock I'll start the class tomorrow. Yeah, Kamlesh, thank you very much. Let me give some example for you. How he created the formulas will be my final explanation for you. Let's see a small idea. So it's a rough explanation for you. It's not required to teach. See here. This is your 2 transistors you have. In the bottom we have is RE. But what happened to RE here is open it is. You can feel that this is an open circuit. Okay, in AC analysis, RE is open here. So we have here V1 my friend, and here we have is V2. Just I'm giving a rough idea how these experts created the scientific analysis, how he created, you can see. This is V1, this is V2. They're all human beings, how they'll create the subject, right? This V1, you have 1 millivolt. This is V2, we have done is 0.9 millivolts. This is the way you're seeing, correct? The first scientist, he has started like this thinking. Different scientists are discussing. The first scientist came and said, alright, V1, V2 are mixing, and V1, V2, V1 are mixing, you said. Then one scientist said that, why can't you take the difference? He said, first point. So first step will be started like this. V1 minus V2. This voltage minus this voltage, he has taken difference this side. And this person started to take V2 minus V1. That means his thinking is, this is your signal, the signal is coming to me, so V2 minus V1. Like this he started first thinking. One scientist said like this. Okay, then other scientist came and said, your statement is wrong, he said. What is the reason is, if you see here, this difference how much is coming is 1 millivolt minus 0.9 millivolt. This is equal to 0.1 millivolt. And this difference is coming 0.9 millivolts minus 1 millivolt, which is coming to be minus 0.1 millivolts. After seeing this calculation, he said to his neighbor scientist, sir, your analysis is wrong because these 2 are not matching. Your thinking is bad. These 2 are not matching because both are same has to come. Because this only will go inside. But with mixing you have to write. So this is not matching. So like that, the first formula has been failed. So V1 minus V2 and V2 minus V2 is thinking is not good. Then the second scientist proposed another idea, saying that, why can't you think like this? Other person said that, this is not the correct way, he thought. Then second way is thinking like this. This difference, whatever you got, why can't you take half of? This is the second scientist came and said, why can't you take half of? Because you are taking 2 transistors, maybe this will take half difference, that will take half difference. Then the next colleague started to apply the formula. That formula, one more scientist said, this is also wrong, my friend, he said. What is the reason is, it is coming 1 millivolt minus 0.9 millivolts by 2 is coming. So 1 millivolt minus 0.9 will be 0.1 millivolts by 2 is coming here. And here, minus 0.1 millivolts by 2 is coming here. So I think this answer is not matching again. So this is also wrong formula. So this is slightly improving your formula now. So what is the extra quantity, where it is going on? 1 millivolt if I go, why I am getting only 1.1 millivolts by 2? Here also, minus 0.1 milli, but the other thing is missing there. So what is that missing term? Then one more colleague came and said to the person, okay, you are only taking the differences, but when two signals are mixing like this, there will be some common factor between these two. Both signals you are mixing like this, definitely there will be common value. When they are mixing, not only difference, we have a common. So then other scientist said, array, where you done the mistake is, you have not kept the common value. Common is nothing but average of these two signals, he added immediately. This is called common value. Whenever you added that, immediately what happened, you can see the technique. This is 0.1 milli by 2 plus 0.1 millivolt by 2 plus 1 millivolt plus 0.9 millivolts by 2 is the common value added. So whatever the remaining term you have, this is 0.95 millivolts you got. This is the term you are missing. So 0.95 millivolts plus 0.1 milli value added. So whatever the remaining term you have, this is 0.95 millivolts you got. This is the term you are missing. So 0.95 millivolts plus 0.1 millivolts by 2, it became 1 millivolt exactly my matching. I think it's matching. That means he said that only if you take difference, the common factor you are losing in the subject. So common value also should present and the differential also should present. Then only it will be 1 millivolt. Here also same story, plus minus 0.1 millivolt by 2 plus 0.95 millivolts. If you add these two, it comes 0.9 millivolts. Perfect. So like this, different assumptions they made, and finally it came as a path. So this is not a derivation purely, this is only imaginative formula in electronics. How they started means first the difference, next to half of, next he made the common factor, then he got the result. This is the story behind how they started the research work on how to make the formula inside with the two mixing voltages. I'm expecting now you understood at least. At least now you understood, I'm expecting. This is the story behind the mathematics. So that's why you should have that feeling to remember this concept. Not only differences, we have the average also in the subject. But difference you should not take only V1 minus V2, you have to take half of the value. Okay? So now onwards, this formula will become the golden formula for the total of designs. Tomorrow onwards, we should not say newly this formula. Okay? One of the best formula and one of the important and imaginative formula in electronics. Most of the people, why they feel tough means because of not understanding the structure. Why it is going inside like that? Why they are mixing like that? The things I have visualized in the class for you. So anyway, tomorrow onwards, the game will start like from here onwards, the subject will be developed. Always remember, whenever you do AC analysis, you have to do two analysis. One is common mode analysis separately, we have to explain. One is a differential mode. So examiner will ask you two different questions. Tomorrow morning at 8 o'clock, sharply I'll start the differential mode, how to analyze, common mode, how to analyze. After that, CMRR. After that, remaining topics. Maybe tomorrow we'll finish that content. After the break, we'll start a new topic tomorrow. That is your op-amp basics is next class for you. Tomorrow will be the op-amp basics. So 2 hours it will take time now, tomorrow. So 8 to 10 we'll finish up this work. So 10 o'clock we'll finish and close the matter. 10:30 is start with the new module tomorrow. That's what basics of op-amps. Okay? Anyway, thank you very much. Today I'm stopping the class. Morning 8 o'clock is the tomorrow time. 8 a.m. for a change हो गया time. Morning 8 I'll start the class.